So in this video, I'm going to show you how to use Excel to create a column graph with error bars, custom error bars representing two standard errors of the mean. But before we get into Excel itself, I want to show you the data set that we're going to be using. We're going to be using a website called Data Nuggets, which has lots of actual data from scientists who sort of tell the story of their data set, and they provide the actual data as well. So this is a data nugget answering the question, how do brain chemicals influence who wins a fight? And we're going to be looking at small organisms called stalk-eyed flies. And you can see a picture here. So I would love for you to, before we get into Excel, stop and take this opportunity to watch a video on stalk-eyed flies, on their aggressive behavior, as well as read through some of the background in this data nuggets. So now that you have a little bit of background on stalk-eyed flies and on the research that the scientists did, now we can actually look at the data. So remember, we were looking at the question of how do these chemicals influence behavior? Or at least what's the relationship between behavior and chemicals. We'll talk later about whether there's enough evidence to say that there is a relationship between them at all. Is there a correlation? And if there is a correlation, can we say that that's causation? Did one necessarily cause the other? But we'll discuss that later. All right, so let's take a look at Excel. So Excel is a wonderful program for organizing information, and we can organize it just in a table form by typing into the cells directly. But then once we have that data there, we can also use it to create graphs. So today's data, we have three pieces of information we're going to be looking at. We look at the battle number. We look at the serotonin levels of the winning fly and the serotonin levels of the losing fly. So that's why we have these three columns of data. So the first thing we need to do after we have this data typed in is to create some summary statistics. So summary statistics do just that. They kind of summarize our data for us. So let's take a look at one way of summarizing the data. So one way of summarizing data is with average, right? There are several different kinds of averages, but we're going to use the mean. So to get Excel to figure out an average for us, we're going to use a formula. And to tell Excel that we want to do a formula, we use the equal sign. So we type in equal, and then we highlight, first we need to say what we're going to have it do. So we want to type the formula average, and you'll see things start popping up. And they're often kind of built-in tutorials. It tells us how to deal with this. So when we're doing average, it means that then in parentheses, we have to put all the numbers we want to average. An easy way to do that is to highlight all of the numbers. So I'm just clicking down and moving my arrow up until I get to the top one. And we do not want to include that column heading because Excel gets really confused if you have any text in there, doesn't know what to do with it. So we want to just stick to the numbers. So we highlight this, then we do end parentheses, close parentheses, and then you can just hit enter. And there's our average, all right? So now we could do this again over here. We could do equals average, open parentheses, highlight our data, close parentheses, enter. And that would be one way of getting this information. Or we could just have Excel do this for us. So it knows that in this cell, it created an average. So if we take our cursor, and you can see it's turning into sort of a black plus, and if we then, once it's a black plus, we click down, hold down, and slide over to the right, what we're telling Excel is whatever you were doing in that cell over to the left, do the same thing here. So in this cell, it was averaging all of these cells in the B column. When we drag it over, it assumes that now we want to do the same thing in the C column. And you can always use this formula bar to check what Excel is doing, because you need to make sure that you understand what Excel is going for here. Okay? So now we have our two averages. So take a look at this. This is a pretty big difference, right? The average serotonin level in the winners was 76.5, and the average serotonin level in the loser was 36.55. But you can also notice, if you look at the data itself, that there's quite a bit of variation here. So we want to make sure that we understand, like, well, could this just be chance alone? Could there just be so much variation in here that this isn't really a meaningful difference, that the difference is just due to chance because there's so much scatter here? So one of the ways of figuring out if our data set is kind of believable, or that there's a meaningful difference between those or a verifiable, a true difference between the data sets, is that we can create some error bars. So let's figure out how much error there is within each of these. So one important piece of information in figuring out sort of how believable is this difference is the sample size. So the sample size is how many pieces of information do we have to represent each of these groups. So how many pieces of information do we have from sort of the winner group, and how many pieces of information do we have from the loser group? So that's called sample size and just represented by n. So we'll add this to our summary table down here. So n, we could just count these up by hand, but we could also just make Excel do it. Remember, to do a formula, we start with the equal sign, and then the formula we want to do here is count. So we type in count. And then we open parentheses and we highlight all of the cells that we want Excel to count. Close parentheses, hit enter, and it tells us that there are 20 of those. And remember that to have this same formula appear in the column to the right, we move our mouse over, hover over it until it turns into that black plus, and then drag it over to the next column, and there we have it here too. So now it's figuring out the count of the C column. And those are not always going to be the same. Oftentimes we'll have the same sample for each of our two groups, but not always. And it's okay if we don't have the same sample size for each group. That's fine. All right, so this tells us how many individuals we have, or how many samples we have to represent this population. So that's one way of sort of giving some information about how believable this difference is, right? If we had averages that were each based on just 2 pieces of information, we couldn't be as sure that there was a real difference between those populations. If we had 100 or 1,000 and those averages were different, we could be more sure that that's truly representative of the whole population. Another thing to keep in mind is how much variation there is within a group. So if you notice, the winner ranges quite a bit, all the way from, 21 I see, all the way up to 190 here. So there's a big variation within a group. So what I was saying before is maybe this difference between winner and loser serotonin levels is just sort of random, right? It's not actually a meaningful representation of the two populations. Maybe it's just a sort of a luck of the draw as we're picking things out. So one way to figure that out is called a standard error of the mean, and it essentially tells you how much variation is there within that group. So to figure this out, we're going to use the AP Biology formula sheet that has some formulas on it, and we'll let that be our guide. So one of the aspects of standard error of the mean is to calculate standard deviation. So I'll type that in here into the summary chart, and then we'll figure out the standard deviation of each of these. All right, once again, to do a formula, we start with an equal sign, and then for standard deviation, we can just start typing standard deviation. So it actually is STD. So if you just start ST, you'll see a bunch of them pop up, but STD gives us a bunch of different standard deviations. Now this kind of goes beyond the scope of this course in terms of the difference between all these standard deviations, but we're going to use standard deviation of a sample, STDEV.S. You can see that on your AP Bio formula sheet, that's the one you want, and the reason here is that we're analyzing data from a sample that we hope represents a larger population. So we don't have all of the results of all of the battles of all of the flies in the world. We just have a sample, and we're trying to see how well that sample represents the whole population. So we choose standard deviation based on a sample. You can double click that, and then again it wants to know what do you want to keep or what do you want to use to calculate the standard deviation. So once again, we'll highlight these cells. When we get to the top, close parentheses and enter. And then we highlight that and scoot it over to the right, and it'll do the same thing over here. So now this tells us a standard deviation. And the more you get to, the more you do these, the more you'll get to know that these are fairly large numbers. These are fairly large standard deviations considering our averages. So that tells me that there's a lot of spread in the data. All right, so standard deviation is one way of measuring the spread of data, but the AP Biology, the College Board, tends to use 2 SEM, 2 standard errors of the mean. So take a look on your formula sheet and see what is the formula for standard error of the mean. So standard error of the mean is the standard deviation divided by the square root of the sample size. And 2 standard errors of the mean is just 2 times that. So let's create a formula here. Now I'm going to put several parts into this formula, but the nice thing about a video is you can go back and take a look at it multiple times if you want. So we're going to do equal because it's a formula, and then it's 2 because we want to do 2 times the standard error of the mean, 2 times the standard deviation divided by, and then in parentheses, square root of the sample. Okay, so let's look at this whole formula. So we have 2 times, and if it helps we can make it clearer, we say 2 times this whole thing. So 2 times the standard deviation divided by the square root of the sample size. And remember, sample size is represented by n. A neat thing on Excel is it'll highlight things based on color. So I don't know how well you can see this in the video, but B25 is highlighted in blue, and then you can see, you can match that up down here. B25, it's kind of like playing Battleship, B25 is blue, that's the standard deviation. Right? B24 is highlighted in our formula as red, and that's showing the sample size. So that's another kind of quick way to check that your formula is pulling the information you want, is by checking those colors. All right, so if we hit enter, we've got our number. And then we can do this handy sliding over trick to calculate 2 standard errors of the mean for the other group. All right, so now we've got our summary statistics, and the next task is going to be to create a graph. Before I create a graph on Excel, I want you to pause and think about what would you want the graph to look like. So draw out on just a separate piece of paper, what would you want the graph, how would you want to organize the graph to display this kind of results? So one thing to sort of take into account when we're deciding what graph to use is how is our data organized? So for example, do we have a categorical independent variable or a continuous independent variable? So first of all, what's the independent variable here? And then second, what is categorical versus continuous? So our independent variable here is the battle outcome. So there are two parts of that, right? 2 categories. There's the winner and the loser. And I may have kind of given it away by saying that there are 2 categories. This is a categorical variable. So it's not along a continuum. There are 2 distinct categories. There are winners and there are losers, right? If we had done this study in a different way, we maybe could have actually come up with battle outcome as a continuous variable. But this is a discrete category. So there are going to be 2 categories. So when there are categories, it's best to do a column graph, because then it shows that these are really different things. If it's continuous data, so for example, the amount of something, then it would be better to do a scatter plot or a line. One way to remember that is that if the in-between has meaning, then we can do a line, because a line tells us then, it gives us information about all of the values along that x-axis. All right, so let's get going here and do the graph. So what we're going to do is we're going to highlight the information that we want to graph. So we want to highlight winner, loser, and the average, because those are really the main things that we want to graph. So we're going to do insert, and we could do recommended charts, but I know what I'm going for here. So I want to do a column or bar, and I really, really highly recommend 2D as opposed to 3D. 3D just adds unnecessary fanciness that actually ends up confusing because it's hard to see where the top is. So unless you're actually 3D printing a graph, which I highly recommend you try once we've got our makerspace up and running, let's actually make some real 3D graphs, but not on Excel, unless there really is an additional variable we're looking at that's useful. So stick with 2D graphs. All right, so here's our basic 2D graph. We've got our winner and our loser. Okay, you notice that there's some missing information here. We'll fill that in a little bit, but first I want to show you how to make error bars, because we spent all this time figuring out these error bars here, so let's use them. So if you click on your graph and click this plus button, Or you can go to chart design and add chart element. That does the same thing. What we want to do is add error bars. And we don't want to add any of these error bars. We want to add our own error bars. So you go to more error bar options. And this is where you can really start seeing the difference between Excel and Google Sheets. So if you haven't done so yet, I highly recommend you download Excel on your computer. In fact, it really is going to be necessary because at some point later in this year, I am going to find a way to assess that you're able to make graphs like this. So if you're unable to get Excel on your computer, please contact me and we can try to figure it out. All right, so go to more error bar options. And then down here, hiding under my little picture, is custom. So click on custom, and then we want to tell Excel what our custom error bars are. So we want to specify value. So the positive error bars, what that means is how far above the columns do our error bars go. So we want our error bars to go above our columns by that 2 SEM amount. So we're going to highlight our 2 SEM, both the winner and the loser. We're going to highlight those. Now we also want that same amount to go below our error bars. So we're going to delete out what it has in here to begin with, and we're going to highlight the 2 SEM. And then we click OK. And there are our error bars. Simple as that. Okay, so here we have our columns for winner and loser, and our error bars are representing 2 SEM. And what this allows us to do is it gives us kind of a proxy for determining if there's a significant difference. And so what a significant difference means in science, it's really kind of beyond the scope of the course, but for right now what I want you to understand is that there is a difference that cannot be explained by chance alone. So if the error bars do not overlap, we can assume that the difference between these groups is not explained by chance alone. So if you think about it, the bigger the error bars, sort of the more variation there is, right? And so if there's tons and tons of variation, if we have error bars that are so big that they overlap, that means that we can't really be sure that there's a difference between this group and this group. It could be due to chance. But if the error bars don't overlap, then we can say, all right, we're more sure that there is an actual difference between these groups that cannot be explained by chance alone. So if your 2 SEM bars overlap, there is no significant difference. If the 2 SEM bars do not overlap, then you can conclude there is a significant difference. Again, this is not perfect. When you take statistics, you'll actually have much more powerful tools of determining significance, but this is going to be good enough for this year. All right, now to finish off this graph, you get to sort of play around with the look of it. You can change the colors of things, you can change the width of the error bars, but I really recommend keep your graphs as simple and easy to read as possible. So if you really want to put all sorts of bells and whistles on it, do that on your own and don't turn it in. The one you give me, keep it simple, keep it easy to read. All right? But things that you do need to have on your graph are axes titles. So we'll add a chart element of axes titles, and we want to have an axis title for the x-axis and for the y-axis. All right, so our x-axis title that we're going to be adding, and you can just double click in here, this is the battle outcome. And so this title should apply to both categories, right? So winner and loser are categories within that variable. A variable needs to vary. So the battle outcome varies. It might be winner, it might be loser. Okay, and now for your axis title over here, this is serotonin volume. And I'm going to pause this just to make sure that I get the units correct on this. All right, so the unit here that was used in this study of serotonin was picograms per microgram. So pico and micro are root words that you should be somewhat familiar with, at least familiar enough to know that you can consult your AP Bio formula sheet. And if you take a look on there, it shows you how big a pico is and how big a micro is. Micro is that funny symbol. It's like a mu symbol. So if you don't know how to make a micro symbol, you can just write micro is fine. All right, so there are our axes titles. We don't actually need a chart title, so I'm going to delete this because instead of a chart title, you're going to do a caption. And what a caption does is explains what you see in the graph in terms of the relationship between the variables. So it's a nice, easy way of giving some text to accompany your figure, and it's wonderful to have captions in scientific articles because it means that you can look through the journal article and read just the figures and read the captions and get a whole lot of information out of the article without digging through all of the text. So give enough information in the caption that somebody could understand it without having read the entire paper. And I can talk to you more about what needs to go in a caption in a little bit, but because this tutorial video is really focusing on Excel, I'm going to stop there.